Okay, so Keysight Technologies, you have fairly recently introduced the Keysight Artificial Intelligence or KI architecture. I guess it'd just be good to understand a little bit as to how the solution portfolio came to be developed and the sort of high level view of what it offers.
Sure. Yeah. Yeah. Great to be here. By the way, Phil. Thanks for inviting me on the show. The Keysight AI, or Kai, as we're calling it for short, solution architecture. It came about when Keysight realized that we're all working on different solutions for the same general purpose, for the same audience. Really, there are a lot of solutions that are geared toward advancing and optimizing the performance of AI infrastructure. That is the new style of data center that's coming about to train and do inferencing for AI. And I think that's we've all been watching AI in the news and talking to some of the industry leaders about some of the challenges that they've been having. And there's been some kind of consistent themes across the board when they're basically trying to build these giant hyperscale data centers. And the issues they have to do mostly with scaling them to be more efficient, handling more data capacity, and also dealing with bottlenecks. So we looked across the entire Keysight portfolio, all the different products that we have for testing and emulation and design, and we put together this portfolio of solutions as a way to kind of signal to the industry that we have a solution for everything in the AI data center development cycle. So anything from pre-silicon design and verification for switching ASICs, all the way to optical component conformance testing, to like network deployment performance analysis and pre-deployment workload optimization. So we put all that together to tell one story that all contribute to the same end goal. We want to help customers, whether working on chips or working on designing the data centers themselves, to be able to create faster and more efficient AI data centers. And we organize these solutions into four pillars, which I'm sure we'll get into later. But it's all about addressing those common themes, those common challenges that we saw. Just to name the pillars for now, we have Kai Compute, which is solutions all about onboard processing and communications. So a lot of the high-speed digital communication between chips on a single server rack, the processing nodes themselves. And then we have Kai Interconnect, that is the interconnections between the servers and the nodes to actually build out the AI fabric. So that's a lot of the Ethernet optical connections. Then you have network, which is all about the fabric operations and the application layer performance of the network itself, making sure that the workloads are benchmarked and optimized. And then there's Kai Power, which is all about making sure that every part of the system has a high level of power integrity and therefore is efficient to allow networks to scale higher without running out of power, basically.
Okay, and I guess it'd be good to ask at this point, why is it, or just why is it so important to test throughout the design and build process in terms of scaling AI data centers? I mean, I'm imagining I don't know whether you do this for, shall we call, traditional data centers, or you felt the need to develop this specifically for AI data centers. So what's changed? What's the particular challenges that requires this sort of testing protocol?
Right. Yeah. I mentioned that we've seen the similar themes across the entire ecosystem. And the three key challenges we found really start with some of the new developments that are happening with AI data centers, which are very different than traditional data centers, as you might know. So the key thing about AI data centers is that they're not like traditional data centers in that traditional data centers have a lot of north-south traffic that servers are being tasked with handling a lot of individual requests, and that goes up and down through a spine leaf architecture. An AI data center might have that sort of structure of a network on the front end for doing inferencing and other type of requests. But the big changes are happening in the back end networks. And that's where a lot of the new developments are happening. That involves a lot more east-west traffic. And east-west traffic is basically the result of how large language models are actually trained. So each task is broken up into smaller workloads. It's called parallelism, and each piece is given to a different node. And the nodes or the server racks are having to process in parallel with each other and communicate with each other in order to process the actual training itself. That makes things more efficient by breaking the workloads down. At the same time, it makes them a lot more interdependent on one another. So the entire network has to wait on the slowest node to finish in order to move on in the training cycle. That can end up having something called tail latency. And tail latency is when one of the nodes is just continuously slower than the other, and it creates this big backlog and a big bottleneck. So that comes to the three main challenges we've seen. One of which is that AI workloads operate far beyond industry standards. I mean, there's a huge demand to increase speeds, to push data centers to the limits, and that creates all kinds of challenges throughout, from the chip level to the network level. And that brings us to number two, which is that these demands are putting stress on every single component. So that's where you have to thoroughly test at every layer, or every layer, but also at every step of the way, to make sure that these components who are being stress tested are actually operating well. Because, like I said, every element in the data center is now much more interdependent with each other, and one weak link can actually bring down the entire data center. If a random transceiver here or there goes out, it's not as reliable. Well, then you're bringing down the entire data center. You're bringing the network to a standstill, and you're wasting time and resources. And the third big challenge is, as a result of that, really, component level testing isn't enough anymore. So you used to be able to do, compliance testing on a chip or a transceiver, make sure that it communicates well with others, and that it follows the industry standards. Well, now with the amount of stress that AI workloads put on data centers, and the fact that they're having to go for 24 hours at a time, and it just gets really hot in there, you have to do not just the physical layer testing, but you have to test it in context of that much of a workload at a time. So all these things really compound on each other. The end goal is you want to make sure things are moving continuously, optimized efficiently, and that just involves testing at every layer of the way, whether you're the chip designer, or you're designing equipment, network equipment like server racks, or you're actually trying to put together the network architecture itself. And there's just so many different elements of it that everyone has to do a bit more to make sure that it stays reliable.
And I'm guessing that you can probably add to that speed, because I know everyone wants to build their AI data centers sort of yesterday, because this expansion is happening. So I'm presuming that what you're doing, the portfolio offers people, whether it's from the sort of design, development, deployment, and operations. Is that what you're doing, is where you're contributing to that, to make sure, I guess, I know you folks from the semiconductor industry, and obviously if you test things too late down the line and you find a mistake, then you have to chain all the way back to where it happens. So by taking the approach you're doing here, you can quickly identify any potential problems or whatever and repair them, so that if you like, when you've got to the end of the process, you can be fairly confident that it's all working, as opposed to turning the on switch and then suddenly finding an error. Is that it in a nutshell?
Right. Yeah. It's all about reducing the amount of cycles you have to go through, being able to identify errors early, preferably in the design stage before you built any prototypes. And that applies to everything. So just speaking specifically about accelerating design or reducing the amount of cycles, Keysight has a portfolio of electronic design automation software, Keysight EDA, and that not only uses AI within it to help. It uses machine learning to help accelerate the actual design process, but the chips you're designing with it are, the new PCI physical layer chips, our new Ethernet chips, the silicon photonics chips. We have software packages that help design those things so that you can have faster memory, faster compute, faster communications on board and between server nodes. So the design automation software has AI in it to help you build these kind of digital twins of your chip that you're working on, so that you can have realistic design simulation, and you can actually find issues while it's in simulation, using emulated traffic, so that you can find the issues earlier, get insights into how to fix those issues, and tackle them before you're going to tape out and you're having to find issues in your first prototypes. But that's just at the chip perspective. Once you zoom out to the network design perspective, that's where you come across if you're a network architect, you're so far zoomed out from the chip layer, but you kind of have the same problem. Building a data center is expensive. Deploying a data center is really expensive, and you don't want to leave the optimization task for when you're sitting in a giant, uh, multi-acre building that's full of these expensive server racks that need to be running. So that's why we came up with the data center builder, which itself is a software that does something similar, but for the entire data center. And it lets network architects actually create digital twins of their data center network and visualize all the AI training workflows in software. So you can see how training is being broken up and shared amongst the various nodes. And you can actually see where the bottlenecks might occur during training. And you can put in different models to see how your network is going to handle different training workflows. And that lets the architect identify problem areas and improve and optimize the performance before they build anything. So, really throughout the process, it's about testing isn't just about making sure that it works, but making sure that, before you build it, that you're really confident that it's going to turn out well. And you're going to save time, you're going to save a ton of money, and reduce the amount of cycles that you have to go through.
I suppose uh, something to ask here would be if folks are not able, before you came along with this, how sort of manual or disjointed was the process that you're describing? I mean, was it fairly I'm trying to think well, it wasn't all that automated, and it was, as I say, done perhaps in silos more than overall. Just perhaps describe, pre your solution, if you like.
Yeah, so what you might have to do is in your lab, you would need, you would actually need to bring the GPUs and your processing nodes into the lab and test them with some version of the hardware. And sometimes you wouldn't even have a great layer of visibility into it. So what Data Center Builder really does is it lets you visualize that whether you have hardware or not. I mean, I mentioned in the case of pre-deployment, but if you have, some of your equipment sitting around, you can generate real AI-like training traffic, which is a massive amount of traffic that's really hard to emulate through other means. Application layer traffic into your system to test it and visualize where things are happening. So the process is a lot more manual in that way. I'll take it to a little bit of a different context too. Say you're designing a PCI physical layer chip or a chip that uses a PCIe bus, or maybe a card that plugs into a motherboard that communicates with PCIe. Normally, if you're trying to do compliance testing on that, you'd have to hook it up to high bandwidth oscilloscope. You'd have to hook it up to a BERT, a bit error rate tester that can generate fast enough PAM4 signals to test the receiver side of that. And there's a whole long checklist of compliance tests you have to go through, and that can take days to go through each little test and check it, and you have to repeat it. And it's really hard to actually figure out what's wrong if you don't pass your test. Well, another aspect of our Chi solutions architecture, the Chi compute pillar, actually has a lot of solutions that take our oscilloscopes and our BERTs and combines it with automation software. And the automation software, with a single click of the button, will actually go down and test your device, whether it's a chip or whether it's a board. It'll actually test every single one of those compliance checklists down, and it tells you if you pass or fail. And if you fail, it tells you exactly where you're failing and where you might fix it the next time. So you're not banging your head against your desk trying to figure out what's wrong with it. So that's just kind of the degree of automation that you get to speed up your development cycle in that area too. So in every way, we're trying to figure out, what issues are engineers having throughout the ecosystem, and how can we make it slightly easier for them. And that's why we keep up to date with the newest standards like PCIe, USB, IEEE, the Ethernet standards, OIF, and make sure that the solutions are kind of know what is going on before you hook it up. So it can just kind of step through that process automatically and make it a lot easier for you.
Okay, and is there you described a lot of the sort of assistance you're providing when it comes to accelerating design development? Is there anything more to do with deployment and operations, or is that a sort of extension of what you've already described, or are there other things you are able to help folks with when it comes specifically to deployment and operations?
Right, yeah. So, and that goes back to the data center builder. If you're able to make a digital twin and visualize things in software, then you're speeding up deployment because you're able to make sure that the workloads are optimized earlier. Being able to visualize every node and every data flow is something you don't normally get when you're working with standard hardware. So, being able to inject actually realistic traffic into it to evaluate the network performance before building it, make sure that you can figure out those things in software a lot quicker. And then when you go to deployment, things will run a lot more efficiently. So that's in general, it kind of speeds that. We also have a lot of other network and security test software that are designed for more, operation level performance benchmarking, and kind of does the same thing. But once you've deployed, you can take your system and make sure that it's working correctly as well. So it all kind of comes together to speed up deployment and making sure things are running well in deployment as well.
Okay, and in terms of the makeup, you've referenced obviously, I think most of them. So you've got the Kai data center builder, and then you say those four pillars: Kai compute, interconnect, network, and power. I don't know whether you want to sort of take them individually, or bear in mind you've obviously referenced them to a certain extent. Top up, what? Yeah, just tell us what you need to, if you like, about each of those. That'd be great.
Right. So just to remind everyone of what the data center builder is, it's sort of the key, the centerpiece, and the newest part of the solution set. It's a software platform for accelerating the design and development of the network architecture and the infrastructure itself. And it's very smart about knowing that you're going to be training AI on it, and there's models loaded into it already, so that it knows exactly what to look for, and you're using actual training data versus more generic data. And you can actually visualize what the nodes look like, and you can see as it goes through the training workflows which nodes are slower, which nodes are working a little bit faster, unless you optimize it. Whether it's a specific node that's slow, or whether it's the way that your software is handing out the workloads and managing everything, you can work that out quicker in software. So you can benchmark your job completion time and reconfigure your network and really optimize the production ahead of time using the most realistic traffic possible. And that's kind of the centerpiece and the thing that brought together the whole idea of let's remarket our portfolio in a way that tells one consistent story, as opposed to being all these disparate elements that some customers in this part of the industry may be familiar with our scopes, some may be more familiar with our network test software. Well, now we're bringing it all together into one idea.
Okay, and in terms of the feedback, I guess it'd be good to understand, because it's I think the solution's been out for a few months now. So, and
Mhm.
I'm sure you talked to folks as you were sort of putting the portfolio together. But what's been the response from the market so far?
Yeah, I mean, it's been really positive. We really put this out there and launched it in late March, and we unveiled it at OFC in San Francisco in early April. And it's been really positive because a lot of our customers know us for our high performance oscilloscopes and BERTs. We have some of the highest bandwidth equipment on the industry. So a lot of people who are kind of on that cutting edge of developing the next generation, they know that they kind of have to come talk to us whenever they want to do these 110 gigahertz signal measurements. And we call those solutions Keysight Classic because they're the things that Keysight's always done back to the HP and Agilent days. But then there's a lot of customers who know us more, like I said, for the network test solutions, for taking a look and doing layer 2 to 3 protocol level testing on their networks and network equipment, but also layer 4 to 7 application layer stuff. And so they know us for that, but they don't necessarily know or even really need us necessarily for the physical layer testing solutions. So by bridging that gap, it's kind of creating familiarity for maybe the engineering team in this part of the company is working on one thing, and then this team is working on another thing, and now they can kind of see the full story and maybe even work together on it. And while the data center builder and AI architecture idea is new, most of the solutions are the ones that we've always had and that we're always been iterating on through the years. So really just tying the story together, and I think a lot of people are getting the story because it resonates with them. They're all having the same challenges, and if we can say this solution compared with this and this and this, uh, tackles those challenges in these ways, I think people will really resonate with that.
Okay, and in terms of the sort of future development of this, the Kai Solutions portfolio, are you planning to either add attributes to the existing pillars or introduce new? I mean, for example, I mean, my background storage networks, so you know, would a storage sort of pillar make sense at some stage? Just what any plans you can share as to how you might be developing the portfolio?
Yeah, I mean, with data speeds are going to keep getting faster. They're always going to be developing new technologies to address capacity and power concerns. So I think at every level, we're going to keep developing the next generation of that. You mentioned, storage and storage and memory is a big part of it. We actually put that into our compute pillar. I didn't walk through the pillars as much detail, but we have a number of solutions for like DDR and high bandwidth memory, and basically a lot of new technologies like UCIe. On the interconnect side, that we're looking at new trends like linear pluggable optics, or linear retimed optics. Both are different ways of doing like a pluggable transceiver to connect servers together, but trying to do it with a bit more power efficiency, a bit less waste. And so we're always, every quarter there's a bunch of new solutions that we put out Keysight that all kind of fit into the Keysight AI portfolio. I think specifically when it comes to Data Center Builder, that software platform itself will continue to have new features added on. Right now, it's mostly about benchmarking performance and emulating and optimize the workload balancing. But in the future, I think that the overall vision that the team's working on is being able to get down to the component level with Data Center Builder. So you might be able to characterize the performance of a particular server rack or a particular a hardware accelerator, a GPU with a Keysight scope or a vector network analyzer, and then load that data into your Data Center Builder and be able to optimize the performance around it or compare different components and swap them out in the software so that you can really figure out what the best elements are to have the best network. So that's the overall vision, is that all these things, while they may be more or less disparate design, test and emulation solutions now, eventually they'll all kind of be tied together to work together. And that's really the key vision. And the reason why Keysight has so many different solutions there is it's not to just own different parts of the test process, but to be able to make it all make sense together, to where you can just have one Keysight solution to tie it all together. So that's the vision, and Data Center Builder at the center of it. But we'll see. There's really no telling what's going to happen with AI data center networks, other that they're going to get faster, and hopefully they'll get more power efficient to where they can scale up without being hugely wasteful. And of course, whatever those new technologies will be, there'll need to be some way to test them and some way to make sure you have the fast enough solutions that can give you enough clarity to find the insights to tackle any problems that you come up with.
Okay, yeah, I mean, I've probably gone the wrong way around. So one more thing I'd love to know about is the Kai power pillar, because clearly if there's one thing that data centers are obsessed with, if you like, it is power, because it's they use quite a lot of it, and obviously with these AI data centers that's going to increase, etc. So yeah, how much of the power from sort of when it arrives, I guess, at the the edge of the site to when it actually gets used inside a cabinet or a rack, or what is it that you're doing?
Mm-hmm. Yeah, so the Kai power pillar it's something it's I think out of all the pillars, it's the one that we're looking the most into developing, because there's a lot of Keysight solutions that deal with power, grid infrastructure power, all the way down to like the power rails on individual boards, the power integrity of those. We have so many different solutions, and we're trying to figure out great ways to integrate them into that. The Kai this Keysight AI solution portfolio is always going to be developing. So right now the Kai power pillar, if you look on our website, is mostly focused about optimizing power efficiency on each of the individual elements. So there's this idea that you want to make sure that you have a good power per bit ratio I think I've heard like if we can get below a picojoule per bit processing, that's a good ratio to kind of be able to scale efficiently. And so a large part of that portfolio is EDA software that gives you better insight into designing with better power integrity in the design phase. But also once you have a prototype, having oscilloscopes with the right application software and the right power rail probes that will actually let you take a look at the relationship between if you have like an AC power running next to a high-speed data, a multi-gigahertz or a multi-gigahertz data rail, they're going to be having crosstalk between each other, and that can create waste, it can create ripples, all kinds of problems with your power. So cleaning up the power performance of each piece of hardware is really key to improving the efficiency of the system as a whole. So that's what a lot of the Kai Power solutions are focused on today. Hopefully, we'll be able to integrate some of Keysight's grid energy stuff into that in the future as we go along. But like I said, it's going to be very developing, and so we'll watch the industry and we'll try to respond in kind with solutions for that.
Okay, and actually, sorry, as you're talking, one other thing occurs to me. So I'm sorry, I've sort of gone in fairly random direction during the interview, but in terms of the network and the interconnect, I'm just intrigued again, sort of what level you're doing, because clearly you've got huge, great pipes, if you like, at one level, and then you've got right down to individual components being connected inside a server or whatever it is. So what in this portfolio are you bringing together all that again? So how much granularity, I suppose, is the can you offer people when it comes to interconnects and the network more generally?
Yeah, I mean, let's just go ahead and go through each of the pillars individually. So we tackled Kai Power already. Go back to Kai Compute. The Kai Compute is really a set of solutions that deal with the challenges on the compute side. So on board each of the server racks that developers are facing. So if you're doing chip development for these AI chips, whether it's a switching ASIC, or it's your GPU communications with your CPU, or how that communicates with your memory elements. There's a lot of things happening there. I mean, you've probably seen and talked to people about how the compute racks are being disaggregated, where they'll put all the memory and storage over here, and they'll put all the GPUs over here. A lot of different ways people are doing that, but the Kai Compute is really a set of solutions that are about helping people, helping developers, develop the next generation of chips to do that. Whether they're doing new things like CXL and making a fabric that way, are working with more PCIe and high bandwidth memory or DDR, kind of more traditional protocols. So the challenge across the board there is that things are getting faster, design margins are shrinking. If you think about right now, PCIe at 64 gigatransfers per second per lane, PAM4, so that's four signal levels going on a single piece of copper, and then you multiple lanes of that. That's a really small design margin. And when I say design margin, I mean in terms of noise and jitter, just in terms of the physical bits, the physical layer communication. Those signals are growing faster and the margins are shrinking. It's actually a lot harder to design products that can meet the interoperability requirements. If you have one company making a chip that does PCIe on one side and another company making the chip that does PCIe on the other side, and they can't even communicate with the bits with each other, then you have a problem before you even get to the protocol application layer of things. So the signal quality of the communication, the digital communication, is really key for data centers on board. So the solutions in Kai Compute are all about helping our customers design, develop, and validate AI-ready high-speed digital chipsets that can handle that level of and quality of communication at the physical and the protocol layer. So what you need to do that is you need high performance, high bandwidth oscilloscopes with good enough signal integrity. The scope itself is not imposing any noise or anything on the signal. You need bit error ratio testers that can generate and do error detection to test how the device on the other end is receiving the signal, if it's receiving it accurately, if it can handle, like, if there's any kind of distortions happening on the channel itself, it can see how well the receiver is filtering those out and getting to the bits themselves. But also, arbitrary waveform generators. That if you're first developing the next generation of PCIe, for example, if you're doing work on PCIe 7, are you working on DDR6? These things that haven't been completely standardized yet. There's no compliance checklist. You're trying to figure out your path finding the technology in the first place, and you need the fastest signal generation to do that. So these are all the solutions that kind of meld together into whether you're automating your compliance or you're starting from the very beginning and seeing if it even works in the first place, to make sure you're pushing that next generation of technology along. So that's a lot of the onboard processing stuff. That's anything happening on the compute nodes in the data centers. We also have Chi Interconnect, and that deals with, like I said before, the communications between the nodes. This is a big topic because you need extremely fast and extremely accurate digital communications. Now, not just the from a centimeter level on a board between two chips, but now you're talking about a couple meters up to kilometers of length of optical and copper cables. So making sure the communication between those is really important too. If you think about how data centers are scaling, there's a term, scaling up versus scaling out. You're probably familiar with that, as well as a lot of your audience. Scaling up is about increasing the power of each node to make sure it can do more itself. So you're kind of scaling up with more racks per node. But scaling out is about adding more nodes. And in order to scale out, you need to be able to connect each of the nodes more efficiently. And all of it goes toward enhancing the data center capacity and the connectivity. And so there's lots of research being done into optical photonics. Most of the data center interconnects are actually optical now. Not very many of them are copper, because you can have less signal degradation over long lengths if it's optical versus copper. So a lot of our solutions in the interconnect area are about include sampling oscilloscopes, vector network analyzers, and optical photonic test tools for testing the integrated silicon photonics chips that are coming about. The chips that actually have optical and electrical sides to them, silicon and photonics attached onto one chip to do that conversion, but also for testing things like optical transceivers. And I mentioned earlier, there's new technologies competing for what's going to be next: linear pluggable optics, linear retimed optics. These are different topologies for where you move that actual copper to optical conversion, because you have to do it at some point. We don't have optical CPUs quite yet, but so you have to go, if you're transmitting between nodes optically, you need to convert it to electrical at some point. So moving that around can actually have a big change on power performance and other aspects of the communications. So we have solutions to actually help you do any part of that development, from the chip development to the transceiver side, are characterizing cables, characterizing the physical interconnects themselves, anything to do with that. I think a lot of people are familiar with like 800G and 1.6T as the current network speeds. And so whether you're testing the physical layer individual lanes, which are running at 200 gigabit per second, or across 8 lanes of that to make 1.6T, that's where a lot of solutions address being able to test those. And then finally, Kite Network, just to come back around to it. Once you have your physical layer connections working well and the communications working, and your devices, your nodes can actually talk to each other, Kite Network is about tackling those complex AI workloads that stress the network performance at an application layer. So even if every component in your system is operating perfectly at the physical layer, AI workloads, like I said before, put an enormous stress on the system as a whole. So the Kite Network solutions are about dealing with the protocol and application layers, and you can use them to test transceivers, server racks, and the networks as a whole with emulated realistic RoCE v2 traffic and other types of Ethernet traffic that are used for AI communications. So if you're familiar at all with the company Ixia, which Keysight acquired a few years ago, a lot of the Ixia solutions are now part of the Kite Network portfolio, as well as new products they're putting out like Data Center Builder, X Network, and a lot of products like that. So think of it as solutions that where you're testing individual components and how they work together, not just the physical layer now, but how they deal with the application layer of side of things.
Okay, I say I apologize because I think I got myself a little bit out of order, but we I think we've covered everything now. And thank you so much for giving me so much time and some great insights and explanations as to what it is your Keysight Technologies are doing at the moment. And it sounds as if there's going to be more. Clearly, the AI world is moving on apace, so be good to catch up as and when things happen. But at least for now, so grateful for your time. Thank you.
Yeah, thanks for having me, Phil. I'm happy to talk about it.
Thanks.